Hello and welcome back students to the next module where we're basically focusing on sums based on physical changes. The question says, calculate the enthalpy change for this particular reaction, and for solving them we have been given 4 reactions. Now let us understand how to write this reaction. The first thing which is given in the data is enthalpy of vaporization. That means enthalpy of vaporization means molecule is getting converted from liquid to gas. That means H2O liquid is getting converted to H2O gas, only then the value is so and so, that is 44 kilojoule per mole. If you see the second given data, that is delta H of F, that is formation. For formation of water, we have to use its respective elements, that is hydrogen and oxygen. And since it is high enthalpy of formation of water, and if you see the value is given as per mole, so we can't change the balancing of water. So we have to write as H2 plus half O2 giving you H2O, only then the delta H value is minus 285.8. The third question says delta H of A, that's atomization. That means hydrogen molecule is getting converted to atom. That means H2 gas is getting converted to 2 hydrogen atoms, only then the delta H value is applicable. Similarly, the delta H of A of oxygen is given. Once again, A means atomization, that means O2 is getting converted to 2 O atoms and the value of atomization is applicable. So this is how we have to convert the given data into reactions. Now we'll be using this reaction to get the given equation which is there. Now what we have to find is H2O gas giving you 2 hydrogen atoms and an oxygen atom. So let us first search hydrogen gas is present where in the equation. It is present in the first equation, but it is present on the product side. So we have to reverse equation number 1. So reversing equation number 1, the delta H value also gets reversed in the sign convention. So we got the first data. Now what we want is 2 hydrogen atoms, and for getting that we have been given equation number 3. That means we have to simply add equation number 3 because 2 hydrogen atom we also want on the product side, and the enthalpy value will suffer no changes, it remains the same. Now we want the third ingredient is 1 oxygen atom, if you see carefully, but in the fourth equation we have been given 2 oxygen atoms. So we have to divide the entire equation by 2, and dividing that entire equation, that is equation number 4, by 2, the delta H value is also getting divided by 2 and the value is 249.0. So the equation becomes half O2 molecule giving you oxygen atom. So if you see carefully which is there, H2O gas we got, 2 hydrogen atom we got, and 1 oxygen atom we got, but we do not want certain ingredients, and that is where equation number 2 is given. But in the equation which we have written, we have H2O liquid on the product side, and in equation number 2 H2O liquid is present on the product side as well. That means we have to reverse equation number 2, and as soon as we reverse equation number 2, the delta H value is also getting reversed. That is, the negative terms becomes positive, and if you see carefully, water liquid on the product side is getting cancelled by water liquid on the reactant side. Similarly, hydrogen atom is also getting cancelled and oxygen atom is also getting cancelled. So we are left with the given thing which we have to calculate. Simply adding and subtracting the values, we get the answer as plus 926.8 kilojoule. This is how sum has to be done. Let's quickly take certain MCQs. The first question says, hydrogen plus half oxygen is giving you hydrogen gas plus Q1. That means that much amount of energy is released on the product side. Similarly, for the second reaction also, H2O liquid plus Q2, that means the amount of energy is released. And what we have been told to calculate is enthalpy of vaporization. So let's start the sum which is there. The first thing, that is the first equation, can be also written as H2 gas plus half O2 gas giving you H2O gas, that plus Q1 is actually represented as delta H is equal to minus Q1, because in the first equation that much amount of energy is released, and that is why by sign convention we have to add minus. Similarly, the second equation will also become as minus Q2, and we have to find as vaporization of water. In vaporization, liquid goes to something called as gases which are there. So if you see, we want H2O liquid on the reactant side, where in the second equation it is present on the opposite side. and H2O gas is present in the product side in the given equation. That means we have to add equation number 1 and we have to reverse equation number 2. So just by taking the sign conventions of delta H, adding equation number 1, that is minus Q1, reversing equation number 2, that is plus Q2, we get the answer as Q2 minus Q1. That means our final option is C. Let's take the second one. A hypothetical reaction X gives 2Y proceeds according to the following equation, and the equation is given, and calculate the value of delta H. Let's quickly calculate that. What we have to find is X giving you 2Y. Is there any place where X is given? The first equation, but is given as half. So we have to double it. So multiply equation 1 by 2 and we get X gives you 2Z. The delta H value is also getting doubled, that is 2Q1. Now we want 2Y, and Y is there in equation number 3. So if we want 2, we have to multiply equation number 3 by 4. Only then we get the value of Y as 2Y. That means 4W gives you 2Y. Then the delta H value will also become 4 times, that is 4Q3. That means we got the given data. That means we have got X, we have got 2Y, but we do not want Z and W. So for taking that, one of the Z is present in the product side, which we have in the equation. And on the equation number 2, we have Z on the reactant side. But what we want is 2Z, and what is given is 1Z. So we have to multiply the equation number 2 by 2 and we get 2Z giving you 4W, and delta H value is also getting doubled. If you see the options carefully, can I say 2Z is present on the either side of the arrow, which is getting cancelled. Even 4W is present on the either side of the arrow, which is getting cancelled. We got the required equation, and if you simply add the equation, that is 2Q1 plus 4Q3 plus 2Q2, if you remove 2 common, we get the answer as Q1 plus Q2 plus 2Q3, which is there, matching the option D. Thank you guys.